Hello there, welcome to the October 2020 paper 2. Here we're looking at question 11. Figure 2 shows a sketch of the graph with the equation y equals 2 modulus x plus 4 minus 5. The vertex of the graph is at the point P shown in figure 2. Find coordinates of P. So P is the minimum point here, so it must be the lowest value on this graph here. A bit like completing the square, x is going to have to equal minus 4 to make that modulus expression as small as possible, 0, because the modulus expression, the modulus operation here, will always make things positive, so the minimum that it can be is 0, so when x is minus 4, that will make it as minimum as possible, will be 0. So then you'll get 2 times 0, so then y will equal minus 5, so therefore the coordinate P is at minus 4 minus 5. Okay, let's move on to part B now. Solve the equation 3x plus 40 equals 2 modulus x plus 4 minus 5. The first thing I think I'll do is I'll move the 5 onto the other side. So it's now 3x plus 45 equals 2 modulus x plus 4. Now remember, how do you solve modulus equations? Let's do a real simple one. If we've got modulus of x equals 3, then what we do is we say therefore x is equal to plus or minus 3. So that's exactly what I'm going to do here, but I need to move the 2 first. Now how could I move the 2? I could move the 2 in two different ways. I could divide it onto the left hand side, or I could also incorporate it into the modulus. I think I'll do that because then that stops the fractions. So it's going to be the modulus of 2x plus 8. So therefore, 2x plus 8 is equal to plus or minus 3x plus 45. So let's solve both of these equations then. So for the first one, 2x plus 8 equals 3x plus 45. If I move my 2x onto the right hand side, that's now just x on that side, and then 8 minus 45, then x equals minus 37. And on the other side, it's going to be 2x plus 8 equals minus 3x and minus 45 once you've expanded the bracket. So let's now move the 3x onto the other side, so that'll now be 5x on the left, and then minus 45 minus 8 will give us minus 53. So therefore, x equals minus 53 over 8, so over 5. So there we are, that's the solution for this equation here. X equals minus 37, or x equals minus 53 over 5. Let's move on to question 3. The line L has equation y equals ax, where a is a constant. Given that the line L intersects the graph of this one at least once, find the possible range of values for a, writing your answer in set notation. So what I'm thinking here is that it's going to have to meet the minus part there. Any time that it goes greater than 2, it's going to intersect. So the graph y equals ax is always going to go through the point 0, 0. That's the first important feature of this graph here. It's going to be a straight line that goes through 0, 0 that has a certain gradient. Now, when I'm looking for this range of possible values for a for which it intersects the graph at least once, so it could intersect it once down here. As soon as the graph now has a gradient of more than 2, it will intersect the graph at some point up here. So it has to be kind of in between this and this. So a very small range of values for x. Anytime that it goes greater than the gradient of 2, I'm talking about the gradient of 2 because the gradient of this graph here is 2. And then anytime it has a negative gradient, it's always going to intersect the graph at least once as well. So we're only looking in between a small range of values here. Remember that this coordinate down here was the coordinate minus 4 minus 5. So therefore the gradient at that point there, if we do difference in y divided by difference in x, between -4, -5 and 0, 0 will be up by 5 and along by 4. And then it'd be the gradient 2. So I would say, going straight to my answer here, A exists in the real set of numbers such that the gradient is going to be in between 5/4. So no, it's not going to be this expression here. So this is the not expression I'm writing there. So A exists in, sorry, that's A. A exists in the real set of numbers such that it has to be a gradient either less than or equal to 5/4 with the union of A exists in the real set of numbers such that it has to be greater than 2. Any negative gradients, but not 0, because actually no, 0 would be fine because it would just be y equals 0, which would be fine. Yes, actually y equals 0 would be fine. So yes, so basically it's just not the graph with equations of gradient 5/4 to 2, because then it would just miss it and miss this graph later on. But anytime it has a graph greater than 2, it will intersect it at some point up here. And if it has a graph of gradient less than 5/4, it will intersect it at some point down here. So there's not much working for that question there. It's worth 3 marks. I've kind of just thought about it and thought about what the gradient is going to be. Important point to note here is that the graph will definitely go through 0, 0 because it's not got a plus c on the end of the equation of line L. But there we are. Yes, that's all I have to say there. So there we are. That's the answer for question 11 there, worth 7 marks in total. Let's now move on to question 12.